Hey everyone, today we are looking at section 2.6 and section 2.7. These sections are all about geometric proofs. So some things we need to start with is we've talked about the Pythagorean theorem, we've talked about linear pair theorem, we've talked about vertical angles theorem. Okay? A theorem, just so we're clear, is any statement that we can prove is true. Remember that a postulate is something that we only assume is true and we cannot prove it. All right. Again, remember from the lesson in 2.5 where we talked about proofs. Proofs are step by step how we solve a problem, how we get from point A to point B. They use logic, they use theorems, they use postulates, they use definitions, and they use properties to get from the very beginning to the very end. So imagine a proof like this. Have you ever seen the activity where somebody is blindfolded giving directions for how to make a peanut butter and jelly sandwich to somebody else? And so you have to tell them step by step exactly what to do without skipping any steps. If you forget to open the bag, then they are putting peanut butter and jelly on the bag. So that's basically what a proof is. It's step by step, how do you get from point A to point B? So there are three types of proofs that we're going to talk about. The first is a two-column proof. So a two-column proof is written in a way that looks like a table. You're going to list the steps of the proof in the left-hand column and the reason for each step in the right-hand column. A paragraph proof is another type of proof, and it takes that two-column proof and basically writes it out as a sentence, each line because it becomes its own sentence. And then a flowchart proof is going to use boxes and arrows to show the structure of the proof. We're going to write the reasons underneath each box and the steps inside the boxes. And we'll see an example of this later on in the lesson. So let's take a look at a couple of theorems that we're going to talk about today. We have two theorems that are similar right here and here. Okay, these are our congruent supplements and our congruent complements theorem. What these two say is if I have two angles that are supplementary to the same angle. So if we were to sketch this, let's say this is 120 degrees. Okay, and that would make this one 60 degrees. So these are supplementary. Well, if this angle is supplementary to this one, and I want to draw another angle that's supplementary to this one, I would draw another 120 degree angle so that these are supplementary and these are supplementary. Well, look what's happening with these two. These two are congruent. So that's what this theorem is saying. And the same thing would happen if it was complementary. All right. We would have two angles that are both complementary to the same number, so they would have to be congruent, just like these were congruent. All right? Another one that we're going to use quite often in our proofs is that all right angles are congruent. All right? So what we want to see here is notice that these first three theorems have names. I'm never going to ask you to actually memorize the name of the theorem. You can always just write basically what the theorem is saying. Okay? So I can write this out as all right angles are congruent when I'm using it as a reason, or I can write right angle congruence theorem, whichever you want. Okay? But it basically just saves us a step. So if I have this angle is A, this is a right angle B, these are congruent. All right, and our last theorem that we're going to look at today is if we have two angles that are congruent and supplementary, then that means each angle has to be right. So if we look, if I have two angles that are supplementary, they have to add to 180. If they're congruent, I have to cut it in half so that this is the same as this. Well, 180 divided by 2, these both have to be 90, okay, which makes them right angles. So if you have any questions on these, go ahead and just kind of write it off to the side and then ask me later in class. So we're going to start with a basic two-column proof. All right? So what I want you to notice in the structure is we have a given statement and a statement of what we're trying to prove. So we're going to start with knowing that these two angles are supplementary and that the measure of angle A is 45 degrees. So I want to write that in my picture because that is given to me. I want to prove that the measure of angle B is 135 degrees. So the way we're going to start a two-column proof is we're going to write all of our givens. Now, I could put all of these in one step, or I could put them in two steps, and that would be more than fine, okay? But since these are all together here, we're just going to put them in one step. So I have that A and B are supplementary, and the measure of angle A is 45 degrees. Notice I am writing it exactly as it is in my given statement. I'm not changing anything. I'm not changing the way it's worded. I'm not changing and nothing. It stays exactly the same, okay? So if angles A and B are supplementary, what do we know that that means about them? Okay, what does it mean to be supplementary? So you should be thinking right now that, oh, if they're supplementary, that means that they're going to add to 180 degrees. And that is correct. So we're going to say that the measure of angle A plus the measure of angle B is equal to 180 degrees. Now, how did I know this? Okay, I got this information from this word right here. I knew that this told me this. So what did I use? I used the definition, and I can abbreviate it as DEF, of supplementary. Okay? So this one word right here told me this was true. That's where the 180 came from, was the supplementary. So that's what it means to be supplementary, is that they're going to add to 180. So that's how I can put that in there. Okay? Now, I know that the measure of angle A is 45 degrees. So I'm going to take this and I'm going to plug it into here. So I'm going to say 45 plus the measure of angle B equals 180. So what did I do? From here to get to here, I plugged in 45. When I'm plugging something in, that is substitution. All right? Now, how do I go from this to this? What do I do to solve this equation for B? I am subtracting 45 from both sides. So that is subtraction. And again, you are welcome to abbreviate, but remember that you need more than SUB because that could be substitution or subtraction. You need SUBS and SUBT at the minimum, okay? And again, as we go through these, if you have questions, just kind of note them down on your paper. Please know that proofs are challenging. All right? You're going to get confused. It's going to be okay. All right? It is a challenge. We'll get through it together. All right? Example 2. Okay? I am given that B is the midpoint of segment AC. I'm given AB is congruent to EF. I want to prove that these are congruent. So I am given AB is congruent to EF. So I'm going to mark that on my picture. I want to prove that BC is congruent to EF. So one of the things that I want you to do in a proof is first things first is to look at it and see, hey, does this make sense? So if B is a midpoint, remember that's the point in the middle. So we know that these two pieces should be the same. Well, if these two are congruent and these two are congruent, it should make sense that these two here are also congruent. All right? So step one is just really look at it and see if you can reason out, all right, how do I get from here to here? So let's take a look. B is the midpoint of AC. That is given to me. So I'm going to find that and write given. I'm also given that AB is congruent to EF. So I'm going to come down here and find AB congruent to EF. This is also information that is given to me. So that's the first thing that I always want you to do after looking at it is find your givens and label them in your proof. All right, particularly when you're given all of the statements like this. So find your givens, label them as given. So if B is the midpoint of AC, how do I know that AB and BC, so that's AB and BC, are congruent? How do I know that this is true? What word from here tells me these are congruent? And you should be seeing the word midpoint. Midpoint tells me that this is true. That is the definition of a midpoint. So it's going to be important that you know what these words mean. All right, now look what we have. I have AB is congruent to BC. I have AB is also congruent to EF. So both of these are congruent to AB. So how do I know that BC is congruent to EF? Well, remember that property that we did in 2.5 where I said, and I'm going to use angles just because it's easier to write. If angle A is congruent to angle B and B is congruent to C, then we know angle A is congruent to angle C. That was our transitive property. Okay, so that's what we're using here. Both of these are congruent to AB. So this is our transitive property. And it's our transitive property of congruence. But again, I'm not worried about you writing of equality or of congruence. But I know it's of congruence because I have congruent symbols. All right. Again, as you have questions, just make note of them on your notes. Let's look at another example. Okay. I'm given that AB is equal to CD, and I want to prove that AC, which is this segment here, is congruent to BD, which is this segment here. Now, does it make sense that since this is the same, like don't write these numbers down on your paper, but we're going to just make up some numbers to make it make sense in our head, okay? But again, the numbers do not need to go on your paper. If I say this is 5, I know that this is 5, right? If I say that this is 10, well, if I look at AC, AC is going to be 5 plus 10, which is 15. If I look at BD, BD is going to be 10 plus 5, which is also 15. So does it make sense that because BC kind of overlaps them both, that these pieces are congruent? All right, so now we're going to look at this without the numbers because I don't want you to actually use it in terms of numbers. Okay, so first things first, after we've made sense of the problem, I want to look and see what am I given. I have AB is equal to CD. AB equal to CD. This is given to me. Okay, BC is equal to BC. So anytime something is equal to itself, that's using one of those properties that we did with 2.5. That is our reflexive property. Now, if I look at this, okay, and I look at these two steps here, what did I do from this step here to get to this step here? What happened? Okay, what do you notice on both sides that's now there? All right, I added BC to both sides. And I can do that because BC is equal to itself. So I added BC to both sides. So this is my addition property. All right. Now, look here. In step 4, I have AB plus BC equals AC. And then I have BC plus CD equals BD. So when I look at these two pieces, here and here, those should look familiar to you. This is why I said you need to write this every single time you do these problems, because proofs use them quite frequently. I'm adding the pieces of the segment to equal the whole segment. This right here is my segment addition postulate. Okay, which says that we can add the pieces of the segment together to equal the whole thing. So if I just look at segment AC, I can add these pieces to equal the whole thing. If I just look at segment BD, I can add these pieces to equal the whole thing. Okay? So now here's the next part that's happening. I am taking this right here, this AB plus BC. Well, what does that equal? AB plus BC equals AC. So do you see how these match here? So I am going to take this right here, and I'm going to plug it in for this because they're the same. Then on the other side, I see that I have BC plus CD. Well, right here I have BC plus CD. What does that equal? That equals BD. So I'm going to take this and I'm going to plug it in to here. Okay, what am I going to be left with? Here's that BD, and here's the AC. I'm plugging these in, so I used substitution. Okay? Any questions here? All right, our next example is going to take the proof that we just did. We're not going to do a different proof, but we're going to take the one that we just finished, and we're going to write it as a paragraph proof. All right? So what I'm going to do here is I'm going to take the first step of this 2-column proof, and I'm going to write it as a paragraph. All right? So, or as a sentence. If I look here, I have AB equals CD, and it is given to me. So what I'm going to do when I come over here is I'm going to write, it is given that AB is equal to CD. So all I'm doing is I'm just taking that first line and I'm writing it as a sentence. Okay? Now, the second line was BC equals BC, and the reason was reflexive. Again, it's easier for you to just look up on your notes, look at the last example. I'm not going to keep jumping back and forth. I'm just going to reference back. So we have BC equals BC by reflective. So I'm going to write, by the reflexive property, BC equals BC. Okay? So then our next line in our 2-column proof was AB plus BC equals BC plus CD. And we did that by adding BC to both sides. So now I can say that using the addition property, I get that AB plus BC is equal to BC plus CD. All right? So that's the third line in our proof that we've just taken and we've written as a sentence. So then our next step, if we look in our proof, is step 4 was AB plus BC equals AC. and BC plus CD equals BD, and to get that, we use the segment addition postulate. So now I'm going to write, so AB plus BC equals AC, and BC plus CD equals BD by the segment addition postulate. All right, and then we're on step 5, which was AC equaled BD by substitution. So I like to wrap up a proof with a therefore, AB equals BD by substitution. So one of the things that I want to clarify and make sure that you guys understand is you're not going to have the exact same wording as the person sitting next to you. Okay, everybody's going to say each sentence a little bit differently, and that is fine. What you want to make sure is true is that the content of each of your sentences is the same. But like for sentence 2, instead of saying by the reflexive property BC equals BC, I could have said BC equals BC because of the reflexive property, or by the reflexive property. That's fine. So things like that are always going to be something that may change person to person, and that's okay. But again, the biggest thing is you just want to make sure that what you're actually saying is consistent. But the way you say it is totally up to you. All right? But I do like to use a therefore in the last sentence of my proof, because it kind of says, okay, here's what we're getting to. Here's what the goal is as we're wrapping up. All right? Again, if you have any questions on the structure of this, please let me know. And again, guys, I understand that this is difficult and this may not make sense. It's okay. All right, right now we're going to be working through proofs together. It's going to be one of those topics that is challenging all year long. All right, we'll get through it and we will take care of you, but you've just got to understand that, you've got to just take some time to think through proofs. All right, it'll get there. It gets better as time goes on. Okay, let's look at our last type of proof. So we've seen the 2-column, okay? We've seen the paragraph proof right here, and the last type of proof is going to be a flow proof. So what we're going to do is we're going to take this 2-column proof that's right here, and we're going to write it as a flow proof, which you can see what it looks like kind of on your notes. It's going to look, we're going to put those steps into these boxes and lines, okay? So first thing that I want to do is I want to go through this proof and make sure that it makes sense to you before we start trying to do anything else with it. So when I look here, I'm given that B is the midpoint of AC. All right? If I have a midpoint, I know that these pieces are congruent. All right? I want to prove that 2 ABs, 2 of these, is equal to the whole thing. Well, if these are the same, does it make sense that I could double this, double AB? All right, that's kind of where we're going here. So if I have a midpoint, I know my segments are congruent. That's what my definition of a midpoint is. What tells me this? This one word right here tells me this is true. Okay. Step 2 to 3, I want you guys to star this step. We're going to use this step frequently, okay? Anytime we go from congruent to equals or the other way around, okay? If I go equal to congruent, my reason is always the same, and it's always going to be the definition of congruence, because that's what that means. If segments are congruent, that means that their lengths are equal. If I have a segment with equal lengths, then those segments are congruent. So that's always going to be the case, whether we're looking at a proof that does the congruent first and then the equals, or it goes back the other way and goes equals to congruent. It's always going to be that definition of congruence. This is the big key right here. Okay, and that's true for angles too. Anytime you're going back and forth between congruent and equals, you are looking at definition of congruence. All right? So I need this to be equal because my proof statement is an equation. So I need to get an equation in there somewhere, okay? Now, in order to do something with this, I'm going to bring in that segment addition postulate. I'm going to say this piece plus this piece is equal to the whole thing, okay? Now, look what's happening right here. I know that AB and BC are congruent. So I'm going to take this AB and plug it in for this BC to get this one. Does that make sense? AB and BC are equal, so I can plug in AB here. And that's where this comes from. Now, so because I'm plugging it in, I'm substituting. Now I can add AB and AB to get two ABs. And I can say simplify, or I can also say combining like terms. Remember, we can use CLT to abbreviate combine like terms. All right, I will accept either piece of these. Simplify is fine, combine like terms is fine. Okay, so hopefully like kind of where we're going and what this proof is saying. The big thing that I want you to get out of the proofs today is that they make sense after we do them. All right, I want you to be able to follow the steps and see and understand, okay, now that it's all done, I see where it came from. All right, that's my goal for you today, and to just kind of recognize the different styles of proof. So we're going to take this proof, this two-column proof, and we're going to write it as a flow proof. So the way that we do this, okay, is our statements go in the boxes. So in a box is the statement. So those were the columns on the left. On the line underneath is the reason. All right. So, and on your papers again, your two-column proof is right above this. So I'm not going to bounce back and forth in the slideshow. You can just look above on your notes. So step 1, we have B is the midpoint of segment AC, and it is given to us. So I'm going to write B is the midpoint of segment AC. And I know that this is true because it was given to me. Okay? What did we get from this? What did this tell us? This told us, step 2, that segment AB is congruent to segment BC. Wrote that a little close, sorry. Okay, and I got that because it was a midpoint. So that was my definition of a midpoint. So this is step 2 of our two-column proof. All right, then we look at step 3. What did this tell us? Well, if our segments are congruent, I know that their lengths are equal. So the length of segment AB is equal to the length of segment BC. And I know this because that's what it means to be congruent. That is my definition of congruence. Now, notice something different here. Notice that this drops down because my step 4 of my two-column proof is the segment addition postulate. Okay, the segment addition postulate is always true. It doesn't I don't know it because of one of these steps. I have an arrow from this box to this box because this step tells me that this is true. I have an arrow from this box to this box because this step tells me this is true. None of those 3 steps tell me that AB plus BC is equal to AC. This is always true because my segment addition postulate is always true. I can always bring a postulate in and it will always be true. It may not always help you, but it's always true. But nothing over here tells me this. So that's why there's no arrows going to this box. So this is my segment addition. Okay? Now, I am taking this AB and I'm substituting it into this BC. So because I'm using something from here and something from here, that's why I have arrows coming from both of those to get to this box. Because I need both of these steps to get my line number 5, which was AB plus AB is equal to AC. Okay, anytime you're substituting, you are substituting from 2 steps because you need 1 step to plug into another. So a substitution step should always have at least 2 arrows going to it. All right? Then from here, we're simplifying or combining our like terms and saying 2AB is equal to AC. So this was simplify. Again, we can also say that it is combining like terms. Okay? So again, I want to show you guys the structure of this flow proof. All right? When we're looking at the structure, it is the statements in the box, the reasons underneath. If one step creates another step, we're drawing an arrow. Now, this one, I was able to write out horizontally, and that's fine. I could have drawn it so that if I had my 3 boxes over here, my segment addition box here, and then I could have drawn it going down this way. I could draw it vertically. That would be more than fine as well. Okay, so there are plenty of different ways that you can draw these flow proofs. They can go horizontal, they can do vertical. If you're running out of room, they can do a little bit of both. But the big thing is the arrows are important. You need to show where each step came from. All right? So if you have questions about that, let me know. Again, I expect you to have questions. I expect you to be slightly confused with this lesson. It is difficult. But what I want is that you understand kind of where it comes from after the whole proof is done. It should make sense. All right? Trying to do it on your own may be a little challenging right now, but it should make sense how to get there once you've seen it. All right? So again, we will go through questions that you have. Don't stress over this lesson. Please don't stress. All right? It's going to be something that takes time, and you only get better the more you do. All right? This is going to be a lesson that takes time. So please don't stress over this one now. All right? So let us know if you have any questions in class, and we will see you soon. Have a fantastic day.